Hi everyone, welcome to Paris, welcome to Sorbonne University. It's been a pleasure to, it's a pleasure to have you today. We're really thrilled about this ongoing, effort to create this intersection between quantum and blockchain. Thanks a lot to Alex and Nico to, being the power behind that and just doing whatever I can to bring all the brilliant quantum people that are here in the room today. So I have 10 minutes to talk about Veriqloud. I'm just going to tell you about one of the things that we're doing that is, I would say, maybe the most mature part of it to some extent, but also uses a little bit of quantum. We heard that from the last talk, that quantum key distribution is the sort of most it's the first thing that you find in the intersection between crypto and quantum. What I want to show you today is how we use it at Veriqloud, or how we plan to use it at Veriqloud, and especially combining it with classical encryption to design secure distributed storage systems. Okay, so when you store your data, everybody would tell you have to replicate them. I hope you use hard drives to back up your data, but sometimes it happens without you even thinking about it. For example, when you push your data to the cloud, it's replicated in cloud availability zones. Or when you watch Netflix, you would very certainly use content delivery networks or connect to content delivery networks to decrease the latency. And of course, because the data now are replicated many, many times, the question that arises is how to secure them. Because if if one of the node is compromised, then you lose your data, or your data are compromised actually. And this is a list of top vulnerabilities in cloud architecture, and of course you need to address all of them, because if there is a single weak point here, then your data is completely compromised. So one solution that works at least to address three of the main properties or security features of cloud data security are, one solution is verifiable secret sharing. And what it addresses at the same time is privacy, integrity, and availability. That you would have solutions to address each of them individually: encryption, authenticating your data, and replicating your data. But verifiable secret sharing addresses all of them at the same time. And the way it works here is very, very short. I won't go into the math here, but what it does is that when you let's say for this use case, when you push your data to the cloud, it would replicate and encrypt them at the same time in a way that in order to recover the original data, you need to recover what is stored on several of the servers. And this several is a threshold that can be parameterized depending on the trade-off that you need between security and availability of the data. And if you look at one server individually, it contains no information about your original information, right? So it's very cool because there's no key involved. There is it's just about replicating on several servers, and it's actually not completely. It's already in use in several security applications. You can find it implemented in hardware security modules or software like Vault. And of course, people that do multi-party computing know it very well. You can build multi-party computing on top of that. Right, so the first thing first is that we have our own implementation at Veriqloud. We have the software CASMAT that you can already use, available from CSP's marketplace or as a white label solution. I won't go into the marketing here, but it's here. It's done and ready. But of course, I haven't told you anything about quantum so far. So now, the idea is that you can combine it with quantum key distribution, and you gain something with that. So first, let's have a look at what QKD networks all around the world look like. This is a picture from a couple of years ago. Now, thanks to European Commission, we have a lot of them here in the European region. what it looks like, right? Sorry, QKD networks today, they only do one thing, which is exchanging keys, but this is fine. And as far as I know, there are 55 test beds all around the world, right? So now in European Union, among the 27 member states, there are 26 test beds that you can access if you're, you know, so I mean, it depends, right? Sometimes it's for the academic, mostly for the academic community, but in particular, we have one here. I don't know if Eleni is still here, but the Paris region QCI is something that has been up and running for already a couple of years. Most of them are, you know, Paris region QCI is at the Paris area scale. So most of these test beds are at the metropolitan area scale, except maybe China. Of course, we don't really know what's happening there in China, but we know that they have a network that spans all over the east coast of the country. And countries like Korea or Singapore, they already put QKD in production, right? You can rent a QKD access if you're in Singapore. Of course, connectivity in Singapore is very, very good. So you can rent a QKD box and connect to the QKD, to a production QKD network. And it turns out that it has been proved that if you combine secret sharing or our application Casmat and quantum key distribution, you get more security, not only for your communication, but also for your stored data. The way it works, right, is that you push your data to your cloud infrastructure, and then it's you use secret sharing to distribute to encrypt. But you use QKD to secure the distribution, and you can also constantly re-encrypt data to force an eavesdropper now. So an eavesdropper that wants to learn your secrets needs to attack several servers all at the same time. So it's really, it's very, very secure. This is not something we have invented. This is known as the Linkos protocol. The Linkos protocol has been implemented a number of times in several contexts. So here in Tokyo, for example, was, as far as I know, the first implementation. It has been implemented in Austria, and of course in Geneva with ID Quantique in the context of financial transaction. So I just want to in the context of crypto assets. I just want to finish with what we have done, you know, in our R&D on this topic. We came up with a new protocol that is an extension of this Linkos protocol that was known before, called Multis. Multis now is a protocol that we proved that you can increase the security by having not one QKD network, but several ones connected with classical communication, hopefully post-quantum crypto, secured by post-quantum cryptography. But it's very much compatible with the picture that we have, right? Remember, the QKD test beds are at the metro scale all around the world, and this is exactly what we can take advantage of. So now, in this context, the security that we get is that the eavesdropper needs to attack at least one QKD network, or attack the servers in at least one QKD network, and either break the PQC, so using harvest now, decrypt later attacks, for example, or break the servers in other QKD networks, right? So we changed the secret sharing scheme compared to the Linkos protocol to achieve these properties. We have implemented it. We are testing it right now on the Friends QCI network. So it's something that is already up and running. And to finish up, right, so what it looks like, what the future of secure storage looks like for us is that we can now, you know, take the Casmat implementation that is already up and running at CSP marketplaces, and we could manage a full QKD subnet in order to strengthen the communication, the storage security. Right. So in summary, we have QKD networks. They are mostly test beds today, but we have here a very concrete use case where you can use QKD as a service or quantum keys as a service to enhance the security of data at rest. The future for us is to have managed services around that. And of course, we're looking at further, as I mentioned earlier, QKD is, the secret sharing, is also a platform for doing MPC. So this is something that we have already experimented in-house. And I won't say more about it, but of course, this is the first step toward the quantum internet, where we try to find not only develop the technology, but also the use cases for existing quantum technologies. Thank you. Yes.
The seminar and excellent work you are doing at Veriqloud.
Thank you.
What I don't understand, why this thing is not already, quite largely, or at least even if not largely, adopted by several of the test beds
So don't underestimate the time for deploying these solutions. We shouldn't underestimate the time for deploying these solutions. We started it, so it's coded. The main developer is here in the room, but deploying it on existing QKD networks takes a lot of time, mostly because, and we'll hear about it later as well, is because the stack, the network stack for quantum networks is not completely fixed. So we come already at the application level, assuming that everything lower is done, which is not the case.
I see.
But it's in progress. It's in progress.
We do not have only 26 tests.
Oh, sorry for that.
So some countries, they have 3
sure.
beds or 4, and some of them are really related only to use cases. So not only for governmental applications, but for use cases, and other test beds only for academics. So I think that indeed we should do an effort to connect your work with these test beds in different countries, so to raise interest and see some of them are really very advanced.
Sure. Thank you.
Just one more question. Yeah. When you say that China has already potentially deployed network, does it mean that they physically pulled optical fibers all the way through the East Coast? Okay.
And satellite.
Okay.
500 nodes through the satellite.
Okay.
Thank you.